Hey, Darth Dragon here, and we're about to do some work with expressions. A straw of length y inches is joined to another of the same length. So we have one straw that's y inches long, and we added to another straw that is the same length or y inches long, like y plus y. Well, how long is this two straws put together? Y plus y. How many y's do I have? I have 2y inches of straw. Each side of a triangle is length p. So to do this, I'll say I have a triangle. Each side is p inches long. What is the perimeter of the triangle? So if I said added up all the sides, this is basically p plus p plus p. So I have a total of 3 sides. I have a total of 3 p's. So we literally write 3p. This one. The figure below shows 6 rods and their lengths. Find the total length of the 6 rods in terms of z. Then state the coefficient of the variable in the expression. So I'm going to add everything up. Now I'm going to go by things of like terms. So I'm going to add like terms. So I'm going to do the z's first. Now all these are the same length. I have 1, 2, 3, 4 z's. And that's added to a 2 centimeter length and a 5 centimeter length. Now technically we could say z is in terms of centimeters, but when I add all this up, I have 4z plus 7 centimeters. So 4z plus 7. We'll say 4z plus 7 centimeters. Now the only thing I left to do is say the coefficient of the variable in the expression. Well, there's no variable here, but there is one here, z. So the coefficient is the number in front of the variable. So 4 is the coefficient. All right, simplify. Now I'm gonna play a little game. When I do variables, I can say, well, I have 3x's plus x's. I have 4x's, so that is 3 plus 1. 3x plus 1x is 4x. And that's simple enough, but if that's confusing, when you see the variable, you can kind of think of it as a noun. So if I had 4 zebras and I added 2 zebras, how many zebras would I have? 4 plus 2 is 6 zebras. If I had 2 violins and I subtracted a violin, so 2 take away 1 is 1 violin. And remember, when we do 1, we don't have to write the 1 there. You're welcome to. You say 1v, but that is the same thing. It is an equivalent expression to just v by itself. And in fact, this version is the smarter version, the more appreciated and accepted version anyways. If we want to simplify, 5w minus 3w. So if I have 5 walruses and I subtract 3 walruses, I don't know why you would subtract a walrus. Maybe it ran away. Hopefully it didn't die. 5 minus 3, well, there are 2 walruses left. But at least the walruses have friends, or a friend. If I have a yo-yo and your sister breaks your yo-yo, you have a yo-yo, you take away a yo-yo, you have no yo-yo. You have 0, you have nothing. I'm going to go ahead and just keep pushing through. So let's get a little bit more complicated. So this has 3 terms, but all of them are the like terms, so we can still combine it. So I have x plus 6x plus 2x. So if we want to do this, you can do it all at the same time, but let's just go slow. 1x plus 6x is 7x. And we still have the 2x at the end. 7x plus 2x, well, that's equal to a total of 9 x's. We can go right here. We have 7x minus 5x. 7 minus 5 is 2x. So I have 2 x's and I subtract an x. Well, that is equal to 1 x. And remember, we don't necessarily write the 1 there. 9x minus 3x. Well, 9 minus 3 is 6x plus 2x. 6 plus 2 is equal to 8x. I want to find the perimeter of this parallelogram. Well, I think about the every side in the like terms. So a perimeter is all the sides added together. So I have a side that's equal to 8. I have a side that's equal to r. I have another side that's equal to 8. And I have another side that's equal to r. So combine like terms. I'm going to look through, and I like to pull my variables to the front. So I'm actually going to add all the variables first. So I have 1r here and I have 1r here. I might rewrite that as r plus 8 plus 8. Well, there are 2 r's here, and 8 plus 8 is 16. So this is as little as I can go. This is as simple as I can go. Because again, these are not like terms. 16 doesn't have a variable, and it's certainly not r. So you can't combine those. So this is as simple as you can get. So this is the perimeter of the parallelogram. All right. If I want to simplify 5x minus 2 plus 3x, well, this doesn't have a variable, so that's I'm going to think about that separately. I'm actually going to take all the terms and I'm going to think about them separately. So I'm going to go through and I'm going to look at all the terms that have an x variable. So there's two of them, 5x plus 3x. 5 plus 3 is 8, so I have 8x. And maybe just check those off. And then all I'm left with is the negative 2. So this is 8x minus 2. And that's as simple as that goes. This one right here, I'm going to do the same thing. I'm going to take all the terms. Now remember, this entire term is negative 2y. And that's important because the biggest issue I think people have is forgetting to keep the negative. So this is negative 2 and that's negative 2y. Don't drop those. Those need to stick around. So I'm going to look for all the x's. I have a 3x. I have a 1x, so plus x. And that's all my x's. So as I'm rewriting this, I'm going to look at all my y's. I have a negative 2y. I have a positive 5y. And the last thing I have is a constant, a negative 2. Combine the like terms, so I can combine these terms. 3x plus x, that's a total of 4x's. Negative 2 plus 5. Well, this is the same thing as 5 minus 2, so that's going to be total of positive 3. So 3y minus 2. So this is 4x plus 3y minus 2, and that's it. And that's it for 7.3 as well. This is kind of a simple chapter, real short. And we'll jump back in it with 7.4 and learn a little bit about the distributive property. So let's think of a different thing than yay. How about I don't know how to spell Calabunga. Imagine that says Calabunga. Bunga, that's not it. Woohoo!